Hello everyone and welcome back to another Sound Blaster video. If you followed my channel, then you have seen the video that I made maybe 2-3 weeks ago where I introduced the MIDI FORGE Symphony. This is a memory expansion board for the AWE64. I thought I have permission from Creative to use their Sound Blaster logo in the top right corner, but unfortunately, well, this was retracted. And now I'm sitting on a lot of boards with a Sound Blaster logo, which I can't use. Anyway, this video is not about Creative and the discussions we have at the moment, but I already asked PCBWay to make new boards without the logo in the top right corner, and these ones should be with me in maybe a week or so. I'm trying to figure out how to proceed with this board. I'm still in talks with Creative, and they did apologize, by the way. I will reveal soon what's in this FedEx plastic bag. But if you want to take a guess, please write it in the comments what's in this bag. But whatever the situation right now is with Creative, it doesn't sit well with me because, well, I want to make these boards available. So since I can't use these for now, I decided to make different boards that are in no way related to Creative. The first one you have already seen. It's the MIDI FORGE Rhapsody. This board will definitely go live once I have the final revision of this board with my logo in the corner. And, well, I decided to make it in white this time because, well, not many people saw that it spells AWE. So I want to make the memory chips stick out in this case. Let's see how the PCBs look when they arrive. I think it might be actually quite nice. This board requires the GAL chip, which requires programming, and you need 16 memory chips. It's a lot of soldering, and yeah, I thought maybe there is a better option. And I designed an alternative, which is the MIDI FORGE Sonata. This board uses 8 MB memory chips. It's a 28 MB board, and don't worry, the final version will not have all these copper wires. Yeah, I had to do a little bit of debugging. This is a development stage. However, after this came this. This board is almost done. I only have to fix one small issue, and maybe I will mention this once this board gets released. But the benefit is that you don't need any programming here anymore. By the way, these are 3.3 volt memory chips, so I had to do some voltage translation. This is the project that I was working on for quite some time to create 30-pin SIM modules. Unfortunately, I was still not able to get this to work. So yeah, unfortunately the 30-pin SIM modules, I don't think that I will be able to release another version where the voltage translation is correct. And the reason is that the frequency these SIM modules operate at is just too high, and I couldn't make these modules communicate with a memory controller on the motherboard properly. Anyway, for the AWE64, this is not a problem. These memory chips work. So now I have a use case for these memory chips. And it's a nice little board. Look at them. They're very small compared to the Rhapsody board, although I think this one looks quite awesome. Anyway, this one here may be a nice DIY project. But then somebody reached out and said, hey, I have a value edition like these two cards, and I would be fine with an 8 MB expansion board. And that is a really good idea. So I created the MIDI FORGE Minuet. This 8 MB module takes only 4 memory chips. It does require a GAL chip, and I'll shortly explain why we need it. But this is another addition for the AWE64. So why do we need this logic chip here? Well, these cards have different onboard memory configurations. This is the AWE64 Value, which has 512 kilobytes onboard memory, so is this. And this is the AWE64 Gold with 4 MB onboard. I wanted to make sure that if you clip this board onto your Sound Blaster AWE64, you get the 8 MB. However, if you plug this card on your AWE64 Gold, the 4 MB would be wasted. So in this case, I would like it to have a total of 12 MB. Then you can load even larger sound fonts with a small expansion board. But that's not all. This sound card can be upgraded. Right now it has 512 kilobytes on it, and I want to upgrade it to 2 MB. And you can do this by replacing this 40-pin 512 kilobyte chip with this 42-pin 2 MB chip. And you have to change some resistors on the card. We'll do this under the microscope. Then I will have a 512 kilobyte card, a 2 MB card, and a 4 MB card. And hopefully Then I'll be able to even extend the skull chip that for this card you will have 10 megabytes of sound font storage. And finally, we will test different sound fonts. I know I made already several videos about extending the memory of those sound cards, and we never heard what can you do with it. So today we'll finally listen to different sound fonts, and I think I will pick Doom as the game of choice. Okay, I think this is it for the introduction. Let's just start with this sound card, which has right now 512 kilobytes. Let's see if we can use it. I don't think I'll be using this card because, well, it is also 512 and there is no way of extending it. You will see later on that there are extra pads on the board. This one doesn't have it. So yeah, this card unfortunately will not be part of today's video. The AWE64 is now in the system, no memory module attached. And if we go to the control panel, we will see that we have 512 kilobytes of available sound font storage. These sound cards were shipped with default sound fonts. You can see here General MIDI, we have the Synth GM for General MIDI. Then you have GS, I think this is also a standard from Roland, and it's an abbreviation for General Standard or General Sound. And finally we have the third one, which is the MT32. This I don't think I need to explain. But there's also a fourth option where you can pick any sound font. So these ones are just 4 options you can pick from. For now, let me just use the default General MIDI file and let's see how Doom sounds like. And you can see that it doesn't take up any space because I think there is some ROM on the sound card itself that has all the information baked in. So there is no storage required for this specific sound font. In Doom, we need to make sure that we use General MIDI. Let's listen to Doom. So I think this is the default soundtrack that many of you will know from Doom. Of course, if you don't have an AWE64 or an AWE32, depending on what type of synthesizer was on the card, it may sound a little bit different. Now we can change how Doom sounds by changing the sound font. What about MT32? There is definitely a difference here. Okay, there was definitely a difference. But now we also have the fourth option where we can take any other sound font. So I already selected one here. It's just one of these sound fonts that fits onto the 512 kilobytes memory chip on the card. So that will fit on our onboard memory chip. Okay, sound font is loaded. .512 kilobyte sound fonts are not really usable in my opinion. I mean, just go with a regular sound font that comes by default and doesn't take any memory. I think this is good enough. Now the problem with 512 kilobytes onboard memory is that you can't load larger sound fonts. For instance, this 2 megabyte sound font can't be loaded onto our card. So what we are trying to do now is to upgrade the memory on this AWE64 Value, model number CT4520, from 512 kilobytes to 2 megabytes. I already protected the surrounding area. There is our plastic connector where our memory expansion board clips on, so we need to make sure we preserve these. And now we'll use hot air to get rid of this chip. And then we are going to put this chip on it. This is a Micron chip. This is a 2 megabyte chip. This is 512 kilobytes. These are the chips that I actually put aside for the Symphony board, but well, they will fit here. So let me get my hot air station and then let's heat up the board and then remove this chip. This is my Aten hot air station. If you're interested in the tools that I'm using here, there are affiliate links in the video description. Actually, it goes to my website and there you will find most of the things that I'm using here. I have my hot air station now set to 300 degrees and 50% airflow. And this chip will go on there, but this will do under the microscope. But before we start soldering, let me thank today's video sponsor, PCBWay. All my PCBs are fabricated by PCBWay, and without them I wouldn't be able to bring you the MIDI Forge lineup. From the Maestro Wavetable board, which is already available on PCBWay's shared project space, to the upcoming Rhapsody, Sonata and Minuet memory expansion for the AWE64. PCBWay also offers other services like CNC machining, 3D printing, sheet metal fabrication and injection molding. If you haven't signed up at PCBWay.com yet, now is the perfect time to get started. This year marks the 11th anniversary of PCBWay with amazing prices and coupons for your next order. Don't miss out on this opportunity, there are only a couple of days left. So, check out PCBWay.com today and join thousands of makers trusting them with their projects. Links are in the video description. Okay, here was our chip before. So this is pin number 1. This is power. This is ground. And it went all the way to here. These last 2 pins here were not used. So we cannot just put the new chip on this card like this. We have to move 2 resistors, or well, 2 bridges. This is a 0 ohm resistor and this is a 0 ohm resistor. I know from posts online we have to move this resistor here and this resistor here. Okay, that looks nice. Now let me get my hot tweezers. Okay, these look good. Now we can solder our new memory chip. Just have to make sure the orientation is correct. So pin 1 is here. This one. Okay. And now the chip should just line up with the pads. If you mod your sound card, don't forget to change these 2 resistors. This resistor was on R19, I moved it to R16, and this resistor was on R18 and I moved it now to R17, and this is for the CT4520. So there may be other models out there where the numbers of the resistors are different, but yeah, you have to check. So this is it for this specific model. Okay, I hope this worked. Let's see if we have 2 megabytes now. Yes, we do. 2048 kilobytes. So this opens up a lot more possibilities for us now. Now we can load sound fonts up to 2 megabytes, and I think I have a few of them. These ones are 4 megabyte. I think I actually have only this one sound font that is 2 megabytes. The rest is all larger. Yeah, so, but anyway, we have one sound font that we can try. So let's see if we can load this one. Yes, and of course, let's try Doom now. Wow, that was a lot better than the 512 kilobyte sound font, wasn't it? Of course, the next step would be to put the AWE64 Gold in the system, because then we double the sound font memory again. So let me swap cards quickly and let's load a 4 megabyte sound font. And the AWE64 Gold is in the system and we have 4 megabytes now. So now we can load even larger sound fonts. The GAS sound font is out of the question because the Gold only has 4 megabytes onboard memory. 16, 18, yeah, these are all, you need much more memory for those. I think I want to try this 4 megabyte general MIDI sound font. Let's see. Of course, now the loading time also always doubles. If you're doubling the memory and we load twice as large sound fonts, loading time also increases. I think this was again better than the 2 megabyte font, but now it's time to get some heavier sound fonts. Since I already have the AWE64 Gold in the system, let me just add the MIDI FORGE Minuet to it. If my GAL programming is correct, we should get 12 megabytes of sound font storage. So let's try that. So if my GAL chip programming is correct, then we should get 12 megabytes now on the AWE64 Gold. And yes, we have 12 megabytes of sound font storage in total. So we got 8 megabytes on top of it. That is basically the full capacity of the MIDI FORGE Minuet added to the 4 megabytes of our AWE64 Gold onboard memory. So what that means is that we can actually load 12 megabyte sound fonts now. Yeah, so 2 megabytes, 4 megabytes, we already got those. 7, there is one. This is a 4 megabyte, 5. 16, yeah, this is not working. 18, 27, these are the heavier ones. 8 megabyte. I will save this sound font for the Value edition. But now let's get a 12 megabyte sound font. I think the Chaos ones are the only ones that are taking the full memory size. I'll take Chaos version 2.0. Let's take this one. Now, of course, loading time will increase significantly because we added 8 megabytes additionally to it. It will take probably 10 seconds to load the entire sound font. So yeah, this was our Chaos version 2.0. Now let me put the Value edition back into the system and let's add the memory board. My goal is to have 10 megabytes usable. I'm pretty sure right now we'll get only 8 megabytes because the expansion board will override the 2 megabytes of the Value edition. This is because the GAL programming wasn't complete yet and I had no way of testing this. So now, since I have a 2 megabyte version, I can work on the GAL equations trying to get 10 megabytes on my modified card. Okay, so how many megabytes do we get? And it is exactly 8 megabytes. So this is going to be the task right now for me, trying to figure out how the GAL equations have to be changed that we get the 2 megabytes on board plus the 8 megabytes so that we get 10 megabytes in total. This is what I want to achieve. I tried really hard to get this to work. 10 megabytes on my modified AWE64 Value edition. Unfortunately, I have to say that I wasn't able to get this done. If you're wondering why I have two different revisions here, this is revision 1.0 and revision 2.0. Revision 1.0 uses the output enable and the write enable signals to control the memory chips, whereas revision 2.0 uses the CAS and RAS signals to enable the memory chips. I use these signals to offset the memory that is on the expansion board from the memory that is on the sound card. In this case, I have a modified value edition with 2 megabytes on board. That means that the memory that is on the expansion board should only start from megabyte 2 to 10. Unfortunately, all of this didn't really work. I was never able to get to 10 megabytes. And then I did some digging and found out that the two signals that are indicating how much memory is on the sound card were wrongly configured. I will go under the microscope in a moment, then we'll see two pull-up resistors, which I modified one of them, trying to pull one signal down that is exactly corresponding to what is in the documentation. But that didn't help. It actually made things worse. When I tried to use the original memory expansion board, the one that was designed by Creative about 30 years ago, it showed up as 0 megabytes. So what this tells me is that, well, either I made a mistake somewhere, or the 2 megabyte version value was never really tested or implemented properly by Creative. And I don't know if this can be verified by someone, but if you do have evidence that a 2 megabyte value or an 8 megabyte gold version exists, let me know in the comments. Also, if you have a SimCon and you have an AWE64 with 2 megabytes, let me know what you get. Do you get 10 megabytes? I doubt it, but I would like to know. I couldn't get it to work, and I think I spent enough time on that project. I want to get this out. So in this case, the Minuet revision 2.0 will be the final one. There is just going to be an updated silk screen in the final revision that you will get over at PCBWay's shared project space. But otherwise, revision 2 is going to be the final one. And yeah, I think this is good enough. So every value edition will have 8 megabytes and every gold version will have 4 megabytes plus the 8 megabytes on the expansion board for a total of 12 megabytes. If you go over to PCBWay, you will not only get the Gerber files, you will also get the schematics and of course the programming for the GAL chip, the equations, plus the compiled code that you need to flash on the chip. I will also have a blog post on my website where you can get exactly the same files and maybe a little bit more information. Okay, so now let's quickly check under the microscope and look at these pull-up resistors just to complete the video. And then we're almost done. So here's one of our pin headers. Then we have the memory chip, the one that I put on this card right now. This is the modified upgraded chip with 2 megabytes. And then below there's another pin header for the other row. Now, if you look next to the pin header, here is a resistor. And this resistor is on one side to 5 volts connected. And this is our pin that goes, I think, to pin number 7. 1, 2, 3, 4, 5, 6, 7. This is our BASEM1 signal. So this one is pulled high. And here, you already see my mod. You have exactly the same setup, but this time it is controlling BASEM0. So before it was connected to the 5 volt line here again and connected here to our pin. So it pulls up signal, this one here. This is BASEM0, the one in the bottom right corner. And this signal is not supposed to be high. If it's high, both of them, then we have 0 megabytes on board. This is what the documentation says. So instead what I did is I pulled this down. So this is now connected to ground. Our pin in the corner here is now connected to ground with a wire. Unfortunately, this seemed to cause more issues. As I said before, when I use now a Symphony board, the one that is built after the original memory board that Creative designed, I get 0 megabytes on the card. So yeah, I think the equations may not be 100% tested with this configuration. Yeah, so what I want to do now is I want to revert this mod. I want to put this resistor back where it was initially, because how it is right now, it doesn't work properly. I will still test if we get the 28 megabytes once I reverted my modification here, and then I think we can call it a day. The larger sound fonts I want to keep for another day when I want to introduce you to the Sonata board, but this will be only coming in the next video. And you can also see that Creative never provisioned for a connection to ground. So basically there is no possibility to easily ground this one pin. That is why I had to install that wire. I couldn't just shift the resistor like what we did with the memory chip. And that tells me that maybe this was never supposed to be. And now we only have to move the resistor back in its original place. And that's it. Okay, the resistor is back in its original place. Now let's see if the Symphony board shows up with 28 megabytes. And this is what I was afraid of. Moving the resistor back in its original position makes the memory board work again. So I really think that these equations may not have been fully developed or tested for 2 megabyte value cards. And this is it for this video. So the MIDI FORGE Minuet is available from now on at PCBWay's shared project space, or you go to my website and you can also find all the details there. If you want to, you can make your own PCBs. You will also find the schematics to this board and also the equations for the GAL chip. There is a source code as well as the compiled version. So this is it for the Minuet. The next video will be about the Sonata. This is a slightly larger board, but it also has 28 megabytes. And exactly as with the Minuet, this project will be on PCBWay's shared project space. You will get the schematics. You will not get the GAL chip programming. Why? Well, because this board doesn't have a GAL chip. And now, of course, I'm curious what you think about this project. Do you think it was necessary to have an 8 megabyte expansion board, or should I just have gone with a 28 megabyte edition and call it a day? In the end, I believe it's always good to have choice. Now, if you don't want to solder 16 memory chips like it is on the MIDI FORGE Rhapsody, then you have an easier project to get you all 64 to 8 or 12 megabytes. And it uses different memory chips. So for whatever reason, if you can't find the memory chips for the Sonata, you can still get the Minuet. Yes, you will get a lot less memory, but it's still an option. And if you do want to get to 28 megabytes, well, then I suggest to wait for the next video, because then this board is going live. If you don't want to miss it and you haven't subscribed to my channel, then maybe now is a good time of doing that. And finally, if you can't build boards like this, yes, I'm going to sell these boards as well, exactly like with the MIDI FORGE Maestro. All the details are provided on my website. The good thing about these boards is that they have nothing to do with Creative. I'm not using any of their designs. I'm not using any of their coding for the GAL chips. So yeah, this is absolutely not tied to Creative at all. And with this, I want to conclude this video. Thank you so much for watching. Thank you for your time. I also want to thank PCBWay for sponsoring my channel and my videos. Without their help, I wouldn't be able to bring the MIDI FORGE lineup to you, which includes the Maestro, which is a wavetable board, and these 3 memory expansion boards. If you do want to support my work, you can head over to Patreon and pick one of the membership tiers, which gives you early access to videos and behind the scenes work. If you don't want to become a Patreon member, that's fine. You can also just hit the like button of this video. That would help me out a lot as well. Thank you so much, and I will see you in the next video. Take care and bye bye.